Hello everyone, my name is Khushbu and I welcome to you all in this statistics video lecture series once again. So in this particular video, we are going to learn about one of the very important topic in context of statistics for data science, that is something called as JET score. JET score will be the agenda of today's session. So I hope all of you might have heard about this JET score. At least you would have heard about the name, right? While learning statistics or while dealing with some kind of project in machine learning. So we will be understanding about what is this JET score, why actually we study JET score, and what are the use of this JET score. All right. So in my previous video, already we have seen about Gaussian or normal distribution. So if any one of you have not watched that video, please go and check out that. That is very important again. So this was the shape of Gaussian distribution or normal distribution, which was also called as bell-shaped curve. Okay, you can understand it as bell curve, right? So there, what we saw is this midpoint was mu, which is nothing but mean. This is just the denoted by this mu symbol. Okay, if I move one step right to this mean, so that will be my first standard deviation, that is mu plus sigma. So this will be the range of my first standard deviation. If I move one more step to the right, so it will be mu plus 2 sigma, means the range of 2 standard deviation. Similarly, if I move one more step, that will be mu plus 3 sigma, and that will be the third range of standard deviation. Similarly, in this side also, in the left side as well, so it will be mu minus sigma. Again, one more step, if I move mu minus 2 sigma, it will be mu minus 2 sigma, guys. Mu minus 2 sigma, and if I move one more step, it will be mu minus 3 sigma. So this is particularly in context to the left side, and this is to the right side. So what happened in this bell curve is the first range of standard deviation will occupy almost 68.27% of the data points, and second range of standard deviation will almost occupy 95.45% of the data point. Here the first range of standard deviation will occupy 68.27%. This is for second range of standard deviation, and 99.73% of the data point will be occupied by the third range of standard deviation. But now, if suppose I want to convert this bell-shaped curve or normal or Gaussian distribution to standard normal distribution, again guys, this shape will be almost same. Okay, the shape will be almost same. So what is the difference between why to convert this bell-shaped curve to a standard normal distribution? This conversion is just done because to convert our data into normalized form. Okay, now to convert from normal distribution to standard normal distribution, the formula that will be applied here is JET score. Okay, so JET score formula, if we apply to any kind of distribution, that is here if we apply to normal or Gaussian distribution, then the type of curve that I'll be getting is something called as standard normal distribution. Okay, standard normal distribution, and this particular shape should have mean is equal to 0, means this point, that's midpoint, that is its mean should always be 0, and standard deviation means sigma should always be 1. So in that case only this will be called as standard normal distribution. Now let's understand about what is this JET score formula. So JET score formula can be written as xi minus mu divided by standard deviation. Okay, now let's take one example to understand it more clearly. Okay, I hope it's visible. So this z-score formula is xi minus mu divided by standard deviation. Now let's suppose I have a data set. Okay, I have a data set like 1, 2, 3, 4 and 5. I have this particular data set, and if I'll plot, suppose I have normal or Gaussian distribution, and if I plot this data set, so this will be like this: 1, 2, 3, 4 and this one will be 5. Okay, this one will be 5. Now if I want to convert this into a standard normal distribution, just try to understand here. Okay, so this is very important. So in that case, this particular mean will be 0, because I already told you that in case of a standard normal distribution, here if you see, in case of standard normal distribution, this mean, that is mu, should always be 0 and standard deviation should always be 1. So for conversion from normal distribution to standard normal distribution, this mean should always be 0 and standard deviation should always be, this standard deviation should always be what? 1. Now let us convert this particular distribution into this standard normal distribution, and you will get a clear-cut understanding. So suppose for the time being I have this data set I already took. So what will be the mean of this data set? Just calculate once. So mean means what? Average, right? So if I took out the average of this particular data set, that is 1 plus 2 plus 3 plus 4 plus 5, and divided by the number of data set, that is 1, 2, 3, 4, 5. So I'll divide it by 5. So what will I get in return? 5 plus 4, 9, 9 plus 3, 12, 13, 14 and 15. So 15 divided by 5, it will be what? 3. So 3 will be my mean, right? Now standard deviation. Let's suppose for the time being I am considering this standard deviation as 1. Okay, now let us apply this z-score formula to this particular distribution and convert into this form. So let's take, I'll be taking the first data point, that is 1. So what does our z-score formula says? It's xi minus mu divided by standard deviation. So what is my xi in this case? 1. Am I right? 1 minus, what is my mean? Mean is 3, right? And what is my standard deviation? C. This is 1 again. So I'll be putting here 1. If I calculate this, I'll be getting minus 2. Right? Now if I take another data point, in this case I'll be taking 2 minus 3 divided by 1. So what it will be? Minus 1. Again if I take this third data set, so 3 minus 3 divided by 1, it will be 0. Now the next one, 4 minus 3 by 1, it will be 1. Now the last data point, that is 5 minus 3 by 1, it will be 2, right? So this is the data point that I got after putting this z-score formula, right? Z-score formula, I got these many values. So as you already know that this midpoint, that is mean, will be always 0. So this particular 0 will be coming over here. Now this one will move to this right side. Okay, and after that this particular point will be 2. Now in the left side it will be minus 1 and this will be minus 2. So see how the distribution form got changed from normal distribution to standard normal distribution, and these were the data point initially we had where mean was like at the mid 3 was present, whereas when we put this z-score formula on top of this particular data set, the distribution that we got is standard normal distribution. What is standard normal distribution? Where we got this mean as 0 and this standard deviation is 1, right? So this is how we used to convert from any kind of distribution by putting z-score formula to standard normal distribution form. Now, one last thing about this Z-score is where does we apply this Z-score formula and what is the exact use, right? So you might have seen in the feature engineering, when we do the feature engineering while dealing with the data set, so there sometimes we need to normalize our data set, normalize our feature. So what does we do exactly there? So there we put standard normalization technique. So how does it happen? Actually, inside what happened that on top of that, we only put this Z-score formula to normalize our data set. For each and every feature, we used to put this Z-score, and after that, the result that we used to get in this standard normalized distribution form. So this was all about this Z-score formula, guys. So I hope you understood that what is Z-score formula and where we actually use this Z-score formula. So that's it for this video, guys. We'll see about some another topic in the next video. Till then, keep learning, keep exploring. Thank you so much.